right, and welcome to another episode of Leadership in the Age of Physical AI. I'm pleased to have Sami back. We've done a deep dive into capital markets for oil and gas and a, a bit of history on Sami. But Sami, for this one, I really want to get in, I want to go all in on the tech side, right? Energy in any form is important. And so I'm keen to understand what the current market, what the tech in the market looks like. We're talking about intersection between technology and energy. Tell us what's going on in that field. Where's tech at? What are we driving towards?
Yeah, I think I spoke a little bit about it previously, right? But within oil and gas, similar to how there is in other industries, right? There is what I would call like your physical AI stack, if you will, or layering of how you might approach physical AI. And it start out as that. Like when people are thinking about it, they're not going like, what is my physical AI stack? It's really just how can I improve my operations, and this is just naturally where it might end up. People look at it and retroactively. However, what I would say is kind of composed of that are similar, again, how I touched on before, like similar to what you might see like levels of autonomy. You're going to see a lot of things like initially being able to sense what is out there, like through your sensors, right? Whether it be a IoT sensor that is, hooked up in your operations and in production space, whether it is a camera on a rig or otherwise. You see cameras now for safety purposes. You see cameras now for, in core efficiency. Some people have it, like I said beforehand, in a rig floor, like making sure people don't come into the red zone. And you have it also in, like, say, a shale shaker where all of your cuttings are coming back from downhole, and you have a camera overhead to be able to understand the cuttings that are coming back, because there's just so much. It's like a whole swath of information that is coming downhole. It's very different than like ones and zeros. It's a real rock, and the way that that rock is cut is really important. How it's coming back, the color of the rock, the type of rock, all that information, a mud logger that position on a rig site can theoretically do in many ways, but you can also potentially simplify that, right? You can also potentially have an AI component there that is on top of a sensor, camera. Companies like Drill Docs are doing that. There's then potentially like a deeper perception layer that is focused with things like, say, anomaly detection. Like, as you might know, you have like these sensors, the cameras that are understanding like what is actually happening first. But then there is the actual like computer vision approach where you're actually understanding what is happening and then adding that AI layer sort of on top of it as well. Anomaly detection right now is like all the trend. You see that everywhere because it's really important for things like predictive maintenance. It's really important for things like in safety and otherwise. If something isn't what it appears, well, we got to flag it. And if there's anything that the oil and gas industry or general energy industry has, it's a multitude of data of what it should look like. And that's where it becomes really, really powerful. You see this also in the utility space with things like power lines. Dash AI is one example that is looking at it from like a vegetation management standpoint, where like you might have that view of what it looks like through satellites and otherwise. But as that satellite view starts to look a little bit different, whether it's vegetation growing onto lines or otherwise, then you need to flag it. So there's that separate layer there. What we're seeing also now is like sort of a decision layer, or and AI agents, I think, is a critical component of that, where you take in that information and then you need to make a decision upon it. Well, that's where like the core component of an agent really becomes powerful. In any given agent, you have like it depends on how you view it. If it's like a core AI agent, then there's like the reasoning aspect, the plan, the actual action that's happening. There's some reflection that's involved there. It's like a loop that you're kind of consistently going through. But that action is where things really start to get interesting. I almost argue that is like a separate layer within the loop of an AI agent. There's also like the planning layer, like the sensing of what is the information is being asked of me. And this is regardless of physical AI or otherwise. It could be an LLM putting in something, right? Some information. Well, you need to understand what it is. And there's like the planning aspect of it before ultimately like acting. With that, you have tooling such as that people are building on, I think I mentioned previously, with like geosteering. This isn't what we did because agents just wasn't a thing in 2017, but
There
you
was no
can
memory that could do it. There was no memory that could do it at that time. So
memory,
yeah.
but you can
But
easily,
interestingly, yeah, but
yeah,
interestingly, we did have agents in there, but it just
we
could
did
not the hardware caught up with the software. That's what's
exactly.
happened the last couple of years.
Exactly. The aspect still exists in many ways, but you can theoretically understand, like you get to a point where similar like a human in the loop, which is ultimately what we ended up with in that situation, because to remove a geosteer in theory, is that worth like the cost of having that individual? Is that worth removing for what in theory is, even if it's a 5% production, right? Millions and millions of dollars. Like in theory, that is not worth removing. You'd rather have that human in the loop. And that's a whole nother conversation as it relates to like AI adoption and people's comfort levels there. But like you can easily see like how you can get to that point to where you want to suggest a decision to be made. After that, like I mentioned in that loop, there's that action, right? And the action, it varies. If there's, a typical agent that you might see in like a digital sense might be, okay, I'm making an agent to go book me a trip to Hawaii. Well, it might make that plan. I might write this all out. It might make that plan. And then it'll tell me like, okay, I found these tickets to Hawaii on United, whatever, this price. Do you want to actually buy it? Right. And then there's that action. Too difficult. Like it's pretty straightforward. There's a lot more it's involved in the back end, but it's very, digital. It's not difficult to create something like that. I shouldn't say that. It obviously is, but still.
Yeah.
But then when you think of the physical AI sense, when you think of the physical AI sense, that's where it becomes really, really powerful because I can't do that in my, RTOC or remote control room or whatever you want to call it, right? Real time operations center. I can't do that in my ROC and then be able to access operations purely digitally. There needs to be some kind of physical component typically that's actually making those changes for the most part within a rig site, within a production outfit or whatever it may be. There needs to be some kind of layer there that's involved. You can also think of this from like a directional drilling standpoint. Otherwise, back in, again, 2017, well before that, you've got like a centralized directional driller maybe that's communicating to all the other ones on like how they should operate, but they're not the ones that are physically making the adjustments to the rig itself because it just didn't really exist back then. That closed loop control is a little bit difficult. Now you have things like there's at the edge, you have different types of actuation that's involved, more smart types of injection, auto frac, and things of that nature that get really, really interesting that people are starting to adapt. And you see a lot more of these closed loop controls that are really becoming impactful here. And all of this to say is what's ultimately being injected into, like I mentioned, those remote operation centers. That's what's all the hype right now. That's what we're kind of really exploring a lot as well in Darcy, because you have these, imagine like mission control at NASA, right? You have these control centers that have all of these screens, all of this information and data flowing to them. And it's very difficult when you have 20 rigs or all these different types of operations that are running in front of you and you're working a 12-hour shift potentially trying to understand like what do I really need to have my eyes on. And some operators are outsourcing a lot of this to a company like Neighbors, like Precision Drilling. Otherwise, again, that's in like the drilling domain. There's other aspects as well, but you can outsource a lot of this. But a lot are also trying to build out these centers internally within their own organizations, and those are real differentiators there. I want to have any specific operators here, but these are the ones that are really trying to understand what is the extent that we can bring in all this information from like that sensing in a layer, right? All this different data, and how am I ultimately then able to make it easy for me to understand when I need to move my eyes to certain operations, whether it's from an anomaly detection standpoint or some kind of alarm or something that's coming out. Is it suggesting a decision for me to make? And then me as a human in the loop, am I able to then say like, hey, go ahead and make that? That makes sense. Or no, this does not look right. We need to address that or adjust it. More often than not, you would hope that ultimately it would be 99 times out of 100 that it's making the right call And there's just that one where, it might be a bad call, but like you need to investigate a lot further potentially, right? That's like the goal where a lot of these operators are really going towards, but it relies on a lot of critical components, I would say. If you don't
I
have
mean,
any layers, it fails, right?
it's interesting to say that, and I really want to get to the automation bit and actually leave a fair bit of time to talk about automation, which I know you have a lot to talk about. But just before that, it's quite interesting because you brought up the whole RTOC and remote control centers, and that's quite interesting because really the space industry started the whole concept of mission control and remote operation centers, and they built that from the ground up. We've never had a precedent of actually incorporating these mission controls into existing operations, different departments. And what sparked it all was a botched mission in Iran uh, back in the 80s. And what's actually happened was the US military found out that there were all these disparate teams not really coordinated, and they came up with the joint control, and our industry has just picked up from there. We've used that concept to build the whole concept of RTOC, which has now gone into mining, which has gone into, now everywhere. It's a standard across manufacturing now. But where do you see that? Where do you see the evolution of that RTOC going, right? And remember, this is the segue into automation. So we have a pretty defined industry now with remote control centers, and that was all about getting all these teams working, these humans in the loop, and basically based off of humans. Now you have a combination of agents and humans. Where do you see that RTOC going? And remember, we're going to jump straight into automation after.
Yeah, look, I mean, there's a lot of challenges and hurdles that I think need to be resolved before you really start to see that next evolution. All very, very, very much hurdles that you can overcome. But I think whether it's RTOCs or otherwise, there is a component of, I would say, trust that is critical to that. And that trust a lot of times is built off of like what is being inputted into any said system that is feeding our TOC. So like the data management layer is a critical component of that. Are we denoising all this data effectively? Are we only putting the right types of data in any kind of operations? You might have like thousands of different channels of data that are coming to you, but what are the ones that actually move the needle, right? And how can I make sure there's no like anomalies and areas that I need to really recover from there? So once you have all of that and you can build out like the explainable piece, that's where you start to really trust the AI. And then that's where like the human in the loop becomes really, really prominent. In our conversations with the industry, this doesn't matter what industry it is, but human in the loop is very ubiquitous across this group, especially given the high risk nature of an operation, both from a safety standpoint and just a capital standpoint. And based off of those two major factors, it almost similar to what I shared before, like a geosteer, you almost need to have a human in the loop. And I suspect that'll be the case for quite some time. I do think that over time, for the non safety critical type of work, we gain more and more trust. And I think we start offloading a lot of these things to an agent per se. And maybe there's other layers of work that are involved there, but maybe you don't need a supervisor that is managing all of this. And as you may have heard, obviously before, like a lot of people think that, everybody is going to become a supervisor of agents and all this, right? I don't know what's true, what isn't true. There's a lot of factors that are involved there. That's probably going to be the case in some form or way. I think it sounds a lot more glamorous than it actually is. Everybody becoming a manager. Besides the
And
point, I
that's what
think,
the that's
yeah,
why the podcast is called Leadership in the Age of. So we're basically redefining leadership. We
yeah.
don't know whether are we going to be, do we have agents or do we have people in the next 4 or 5 years, right?
Well, a lot of this also is like the Jevons paradox situation, right? The more that you use these tools, the more of like the demand that kind of comes from it. And I do believe that will be the case. What these roles ultimately end up becoming. Well, I don't want to derail your podcast, but I think there's a lot to be said there. I think it will evolve. That is for certain. I think, how we manage this stuff becomes really, really impactful. What is actually ultimately shared to said supervisor does change dramatically. So as I was sharing before, they may not be a human in the loop for every one of those tasks that they may have had. Maybe instead of like, ABC tasks, it's starting to evolve into only like A and B that are really, really critical. And slowly that kind of changes and changes. I think there will always be for certain very safety critical tasks that are done, you'll almost always have a human in the loop because potentially lives are at stake or other things of that nature. You may lose the well if you make a dramatic change. We're just not at that level of comfort in the industry, but it will evolve. So I do see an ROC or RTOC or whatever it may be evolving in many ways as it pertains to that, but it'll take some time.
So you're sort of saying, I mean, I think where you're going with that is we're basically seeing the evolution of the RTOC becomes a key part of how we manage heavy industries, and that overlaps a point where automation naturally evolves
Yeah.
from an RTOC setup.
I think so, right? Especially as you get more and more of these sensors, of these data points that are coming to you. Of the automate, before I touch on we're going to touch on the automation part here in a little bit. But you start to see, like, if I need to, going back to what I was sharing before in that little framework beforehand, right? If at the very end of it is, or middle of it, I forget exactly where I was at with it. If I need to act, right? Similar to like what an agent is doing, if I need to ultimately act, well, there's some things that like I can flip a switch and like there's an actuator that turns off or whatever it may be. There's other things like maybe now I'm working with a different type of innovator, like a pipe crawling robot, like with Eric's technologies that is now involved. And I'm able to get that information back to ascend for like asset inspection and like pipe integrity. And now I'm able to get that information and then I can make a decision based off of it. It may not be in the ROC, but it very well could. It can be from an engineer, whoever it may be. But now, like, I have all of this disparate forms of data and information. You could think of like a ROC, it's just a great example for it, as like this brain behind everything that is ultimately kind of feeding and then going out and making these decisions and actions. So it does ultimately evolve. Like I said, the automation part does change quite a bit. There are just like, in any kind of, well, in any kind of like digital wave, I say that's kind of come through over time. People want to experiment and try things, and you see a lot of this stuff grow. And we saw this very clearly with like generative AI. You start to see though the governance slowly come back, right? That slowly will eventually come, and then when it does, then that's where people are really starting to look at some of the commonalities with any of these digital waves, data, the trust aspect, like how do I feel about from an adoption standpoint, all of those start to rise. And it's going to affect every aspect that, AI might touch, whether it's, a robotic crawler or whether it's like a rig floor operation type of work, or otherwise. So all will change, I think, over time. We've seen a lot of these trends beforehand. I think it's going to continue to rise and grow though going forward.
Now, I think it's worth noting also that we come from a similar project. We're working on automation for drilling rigs, and we know that some of the challenges where we could not really, in all good faith, could not commercialize some of this tech was it was unreliable, right? And so we're basically looking at a like sort of, I would say, a post AI world where we've got some of these tools to really clean the data that we really could not do, 10 years ago when we were working on these models. So talk us through this whole your automation journey and where do you think that's going, right? And what are the technologies that need to evolve? What needs to happen for automation to become a thing?
Yeah. Automation is an interesting one because I'd argue that like a lot of people see automation as this grand final destination that we're all kind of going forward with. There's a lot that's
Final
involved.
destination.
Maybe those are poor words. Maybe final destination isn't really where we want to go. But maybe that's the case. No, but you do see nowadays that is like the perceived goal in theory, right? There's a lot of ways to slice that. There's a lot of different paths to get there. It may not actually be like that final goal because there's a lot that's involved still with it. And automation, the definition of it, like it could just be repeating the status quo just autonomously, if you will, right? To use the same word. It's just doing that on repeat. The innovation factor where like AI really starts to become, why that's so important is because if I can innovate and I can see patterns evolve and then corrects my patterns, some kind of like reinforcement learning or otherwise, right? That's where it starts to really get interesting. Nonetheless, not to get into like any of that area. As I mentioned, like when you think about like the overall like AI stack that is needed to achieve, an overall comprehensive like AI goal, I would say there's new technologies that are coming out across every layer. It's not like there's no one layer, I would say, that is more important than the other because we need all of these different layers to improve over time. The automation ones are where that gets like probably a lot of the, attention grabbing headlines because I can now do this automatically. We've seen I won't call out any companies, but like we've seen these rigs of the future, maybe I'm calling out companies by using marketing taglines, but like we see all these, what do these futuristic rigs really look like where everything is fully automated? And we've seen this for decades. Unfortunately, we've also seen a lot of companies try to do the full stack of like automation and then go bankrupt. That happens quite a lot, especially with the complexities that are involved in the rigs. So now you're seeing these individual components that are being automated. And you've got like interesting companies like Neighbors that are putting together all these interesting components. And like, I mentioned things like pipe crawlers and all that, but you also have things like, again, I'll use drilling as an example just from my background. Like if I have something that's bringing up pike automatically, and then I'm stacking it into my fingerboards up top, and then I'm able to actually make those connections using an automatic ST80 or whatever it may be, and then all these other specific aspects that are kind of involved. You're starting to connect them. It's very modular in many ways. But like I mentioned before, to enable these modular components of automation across any kind of operation, there's the other previous layers that need to be done right first, whether it's from a sensing standpoint. Like we see the evolution of these sensors improve quite a bit. Everything from like the edge computing part, like I think I mentioned Armada beforehand, who's grown quite a bit in prominence, all the way to, uh, uh, like acoustic vibration sensing of like compressors and things like that, where I can then understand like, are there any anomalies that are coming out from this specific piece of equipment? And if it is, then I need to flag it down to another layer, right? And they're going to make a decision. Or it's a full integrated stack and I can do it all in one. All of these kind of come together, but they're improving every aspect, every layer to ultimately then prop up and make automation theoretically possible, I would say.
No, that's amazing, right? Like because I don't think a lot of people understand how you need one failure for the whole automation stack to fit. And I think you learned that the hard way. So you could build your house of cards on automation and have one component, one sensor fail, and the whole thing falls apart. And you see that, say, some of the pioneers of, automation at its, level 1, level 2 automation, Boeing, Airbus, and the whole aerospace industry, and what they have done. And they've went through years and years of failures before they sort of refined and managed to build a whole management system around the automation, which people don't take into account. People think it's just purely a technical task, but it's not, is it?
No, yeah, it really is it. To kind of bring this full circle, one of the core components that we see nowadays is like this digital twin in many ways that allows you to be able to like do a lot of this stuff. Anybody that really knows me knows that I really don't like the term digital twin, and it's evolved quite a bit. But in theory, like that is similar to like that metaverse layer that is critical. Like it's always there. It's more of a marketing term more than anything, but you need all that aspect, feeding all that data. And it's similar to what we did back in my work at Shell. You need all that information to be able to then understand, like, is this something I can automate? What happens if I automate this? What happens if I make these certain moves? And then looking at like, say, a digital twin or otherwise, or some kind of scenario analysis or modeling, and then say like, okay, if I do this, then what happens? It's the if this, then that, right? Type of approach in many ways. That's kind of what's happening in a lot of these systems today. That's making things like automation potentially possible. Doesn't always need to be as complex as something like that, where you're seeing a lot of the complexity start to arise as innovation starts to grow in this industry.
No, absolutely. Because I love the work, especially what NVIDIA is doing with their sort of
On you.
simulation layer or the digital twin, which is I think, yeah, which is a silly term, which was but a good marketing term. And I think people understood, and it's become a category in the market. But I remember a conversation I had with a couple of Norwegian scientists back in 2008, 2009, and we were basically talking about digital twin wasn't a thing at that time, right? And we were basically talking about how sort of sub-level physics is going to help change. If we just had the compute facilities within these industries, we could actually fundamentally change the way we make decisions, the way we construct these things. So really, when we're talking about rigs and to, people who are sort of from the mining world who listen to our show, and they use rigs in mining as well, but it's fundamentally construction equipment and heavy hauling, heavy moving. That's all that is. But sequencing it to get your desired results is a quite a complex thing, which traditional industrial control systems just could not do. Or if you did it, it's just prohibitively costly. It's so expensive that the economics of a project just does not make sense. But now with sort of so what we're talking about is this layer where we can predict things. It lowers the cost of automation and brings automation more mainstream and commoditized automation. And some of that work where NVIDIA is doing is actually, I think it's quite fascinating, especially their Isaac Sims and the Omniverse that they've built, which I think is a better physics model than say what Meta was doing with their metaverse.
Yeah. I'm glad you mentioned like the physics aspect of it. I do agree. I think they're making a lot of strides in that way, and I think it's improving a lot of what's happening in any kind of like heavy industry, or whether it's in the mining space or the oil and gas space. There's a lot of moving parts that happens, and especially in oil and gas, anything downhole, there's a lot of physics that happens as well. A way to get a lot of trust and adoption comes with things like fusing physics and AI. And what you're seeing now are like these physics informed neural networks, or these pins, right? Types of approaches that are really starting to take center stage, because we will understand that, okay, if I can model the real physics that are happening here, forget any of the AI stuff. Like, I understand the physics as an engineer. I don't understand the potential black box that's happening, but if I kind of fuse the two, could be something really special happening there. That's what we're starting to see in this space. You're starting to see it also in a lot of other industries as well. So it's certainly an area to watch out for, especially as we start to see the fusing of digital twins, automation, different hardware technologies kind of fusing with the software space, and this whole space kind of just evolving over time.
Well, I think we'll have to leave it there. We're past our time for this one, but thank you so much for coming aboard. It was absolutely brilliant. But I think you've got to hold that thought. I think we need to get you back at some stage and talk to you a little bit more about automation. And the major reason why I talk about automation there is drilling is actually becoming a thing in mining. So we've been working with a couple of projects where they're trying to adopt the whole continuous mining techniques and integrating it with what oil and gas did over the last sort of 100 years with their drilling techniques and get a continuous flow. And it becomes all the more interesting for things like rare earth metals, where processing is prohibitively expensive. It's incredibly complex. Well, there's rare earths everywhere. But it's just the fact that trying to extract it and refine it in the Western world is still not a thing. And drilling is kind of seen as that bridge to actually bridge the gap and make it possible. So
Yeah.
watch the space. This is potentially going to become much, much, much bigger in the next coming years if the technology evolves and then automation becomes a critical part of the whole stack. So we definitely want you back talking about some of these things. But for now, this is all we have time for. Thank you so much for your time, Sami. Really appreciate you coming on board.
Yeah. Tito, pleasure as always. Thank you again.
Take care.